everyone. Thank you for joining us today. I just want to introduce myself first. My name is Joyce Young, and I lead marketing for Pico.
And I'm Sarah Werner, and I'm the product marketing manager for Pico.
And I'm Steve Wishaw, and I lead the product team.
If you follow us on LinkedIn, Steve is probably a familiar face for you. Over the past month, we have been dripping video series from our season 1 of the How to Build Smarter Netflix type of series. And today we want to peel back that onion and talk a little bit about why we created that series and how we feel like it addresses the majority of problems that discrete manufacturers face. So let's dive in and go on to the next slide. If you remember anything from today's conversation, we want it to be this: you can be more productive with everything that you have already. So that means the tools that you have from Home Depot, the devices that you purchase off of Amazon, the staff that you have, all of those things and people can work smarter for you if you help connect the dots and include software and hardware integration. Not everybody wants to sign up for a manufacturing makeover. I think it's glamorous for vendors and consultants to think that they can be Chip or Joanna Gaines, come in and help you completely renovate your manufacturing processes. But for an end manufacturer, that can feel a lot like open heart surgery. Not everybody wants to expose their bad work instructions and their poor processes. We felt like the next best thing, it was to pick an application, a real world application with characteristics that everybody can learn from, and then help demonstrate how to error-proof that application so that's built correctly the first time. So this is probably a good time to ask you, what are some areas in manufacturing that you would like to be smarter with? Drop those down, and those can be anything from training to worker guidance to tool integration. Go ahead and let us know. And now let's talk about why we focused on industrial equipment assembly. It's a diverse application set, and it ranges from washers and dryers to box build assemblies, robotic arms, pressure fryers, MRI devices, additive manufacturing machines, huge, wide, diverse applications here. And they all share same or common characteristics in terms of they are low volume, high complexity builds with lots of components. And so we felt like there was a lot of use cases there to demonstrate how to actually error-proof those applications. And we also created a guide to help industrial equipment manufacturers learn how to error-proof that. So let's drop that also in the comments so that it's easy for you to find and download. Let's move on to the next slide and actually hone in on why we picked that application that we did, which was a desktop printer. And this is actually pretty cool because Steve and I both came from additive manufacturing. So this was very relatable to us. Steve, why don't you talk a little bit more about this?
Yeah, absolutely. Thanks, Joyce. This is a good application of that industrial equipment that Joyce was mentioning. This is a home-built DLP or projector-based resin system for 3D printing, a far cry from those that are commercially available. That are on the market. But this is a really good example of why we want to make sure we can document what we're doing appropriately, because this is a complex assembly. There are hundreds of parts, most of them with critical to quality components. Even those with the filament printers at home maybe know that 3D printers and additive manufacturing can be very sensitive if things aren't quite tuned correctly. Those little screws that either level the build plate or make sure that the filament's coming through, or in this case, that our projector is getting that right image with the right pixel quality available on the instructions here. It's all available here for us because we want to make sure we are doing things correctly. So these are very sensitive pieces of equipment, again, ranging from additive manufacturing all the way up to those examples that Joyce walked through. But we picked the Ruby desktop 3D printer here because it had a publicly available set of work instructions to us to be able to base this content on. This is not a roast of the Ruby printer by any means, but it was a publicly available set of instructions. It's a great piece of equipment, and we wanted to make sure that we did it justice, but at the same time, it's a good opportunity for us to improve on because, again, there's a lot of those small components. There's some torque traceable elements that we want to make sure things are fastened correctly and we're not breaking anything. And at the end of the day, we want to make sure we know exactly what we put in this thing for lot traceability. So on the next slide, we're going to start talking about some of those improvements that we made to the content overall. So when we talk about the instructions here, we want to make sure that we're improving on what is available. And you can see these instructions available online. It's dozens of pages. It's a infinitely scrolling PDF, essentially. And I know a lot of you that have SharePoint or the equivalent PowerPoint versions that you've downloaded or exported to PDF or have these instructions available on the production floor. It's a very good example of those dusty binders that are sitting out there. There's a bunch of content. It's potentially disorganized, and there's a lot of text. It's really important to have this as a reference for, your ISO 9001 or even more. Concretely, the AS 9100 for aerospace or 13485 ISO for med device. This is all a very thorough documentation method, but it's really hard to quickly find that information right away. That there's a limited set of information, there's no videos, no linked content, which I'll explain what that means in a little bit, or communication with other systems. This is, again, an example of a PDF, but we want to make sure that we have this content available to enable those operators that are successful. And I'll show what that means on the next slide.
Hey, Steve, just pause real quick. I think it's also worth pointing out to some people listening in, they might actually think, if we go back to the previous slide, they might actually think those work instructions look good because at least there's colorful images and there's more than one.
Exactly. There's you can be able to look up these instructions and see more examples on the Ruby Instructables as well. But there's potentially a dozen pictures for each one of these steps, and the content is there. But what is the order of the content? How do we make sure we're doing things in the right direction? That which picture is actually the most important? Which ones are references? When we have this type of content and structure, it's really hard to discern what the most important thing is versus here's a bunch of extra stuff in case you forgot something.
Yeah.
So when we talk about these work instructions, this text is really important to highlight those differences. There's still a lot of text in both scenarios, but it really highlights that section of what do we want to do first, what do we want to do second, et cetera, et cetera. This content of putting the text blob is good for being extremely thorough, but it really helps differentiate between today's my first day or my second day on the manufacturing floor, or it's the end of the quarter and I'm shifting over from the shipping department and I'm helping out my assemblers versus I've built this thing a bunch of times and I just need a reference. This clear, concise structure allows us to be able to document between here's all the information and here's both the sequence and I forgot what step 3 or 4 is. I need to just reference that very quickly. So organizing and just changing that text over to be a little bit more clear and concise, even if we are doing all this on the same step, it really helps us call out exactly what we're trying to accomplish in the right sequence.
And then also to chime in here, Steve, we did a whole webinar on this for anyone that's tuning in that wants more examples. Becca Resnick, who's an expert in work instructions for all industrials, she outlined multiple examples of what good, better, best looks like when it comes to work instruction writing. So we'll pop that down here in the comments as well for reference.
Yeah, it's my favorite webinar that we've done at Pico just because of how valuable that content is. Even if we're starting small and we'll reference those things later on of what we can do to get started, we want to make sure this content is accessible for everyone that needs it and really documents what we're trying to do. And the next slide is a great example of this because we're calling out specific features as needed. So when we're building our work instructions, we want to have these tools accessible and familiar. So this is very similar to tools like PowerPoint, Google Slides, because we want to enable our manufacturing or process engineers to set up the instructions as they're used to seeing them, but we want to present it in the operator in a way that makes the most sense. So when we annotate those images, it's not just the lines, the arrows, which is a good baseline, but when we layer in those sequential steps, we can layer in hyperlinks for additional image and pictures, integrate to an ERP for a reference bill of materials and work orders. We can really queue up that structure to say, what are we doing in the right order, and have that content available. So for example, if I'm looking to install those 4 brackets, I can link a picture directly to that text. When I click on that text, it'll pop up an image for me and really highlight exactly what I'm trying to do. Again, it's a good reference, but it stays out of the way for the people that might not necessarily need to have all that content over and over again. So we tried to not be overwhelming, but still give that content that's needed. And we still have that high level information that we would expect to see in our ISO 9001 or other quality documentation environments. So as we transition from what do these work instructions look like, we need to integrate some other aspects of our technology stack, both in hardware and software, to enable that, because it's not just that work instructions or worker guidance. If we want to really start talking about error proofing or other items as we start documenting our process, we need to have those tools available from other, again, hardware and software sets to be able to document that. So when we talk about integrating smart IoT tools, we've got a pre-populated device library available to make sure that we have that repeated work done out of the way. So we've got a question of other, what other smart tools could we integrate with Pico, but we have a pre-established device library ranging from a low-cost static camera next to a upscale smart camera on the lower left-hand corner there that is both records images as my simple visual inspection. I have this to check later, versus that overview camera again on the lower left there with the lens that can really check to see, are all my features in place. So when we're doing an assembly, we can make sure that the bolts are in the right place, or we've torque marked accordingly, or there's no defects or other quality issues. And on the upper right, we've got things like a laser marker or a simple label printer or barcode scanner to really start making sure that we're collecting that information. Next to that is a Pictolite example when I'm pulling things from bins, and I have those bins here on my workbench with me. When we pull those parts out, are we pulling from the right bin? Are we detecting that we actually put our hand in to pull those things out? It's a great way for us to document, are we actually going to the right place to pull those parts? The other applications are precision fastening, which is our favorite one to talk about in assembly, just because that's the critical to quality feature that really starts to affect things. So on the next slide, we want to talk about some of that no-code integration. What I mean by that is we have these tools available. How do we start communicating with those? And our device library is available on our website, ranging from badge readers, smart cameras, torque tools, measurement devices. All of these has standard industry protocols they communicate with. All torque tools are typically over open protocol, sometimes Modbus, but that allows us to enable and disable those tools. All those label printers communicate via a specific template. Zebra is a great example that they have that ZPL software. We can update all those text fields as we might expect to make sure that we're updating and refreshing that information as much as possible. Because one of Pico's value props is really error proofing the digital process, we want to make sure we're adding all of those commercially available tools every month. As part of that YouTube series that we've been talking about, we have the full suite of tools available, ranging from demonstrating a Culver inline torque tool, some barcode scanners, and really just documenting everything we're doing via these connected tools, because we want to make sure that we're error proofing as expected and capturing all that relevant information that we would like to as part of our overall process. Because we're talking about traceability, I think the next slide is a good place to start, that we want to talk about how we're capturing this information. So those barcode scanners and label printers are important, but how do we document between something that happened internally versus something that happened at our customer site? And this is a great example, again, referencing our DLP 3D printer here. When we've calibrated it internally, we know all the sub-assemblies, circuit boards, and other components that went into this thing. When it arrives at a customer site, how do we make sure that we have everything associated with it and document accordingly? It's the difference between I know I did something versus something happened in shipping versus something happened during the unloading process. Accidents happen, right? But when you're shipping industrial equipment in large wooden crates, things can jar loose. We want to make sure we have this traceability record as appropriate. So there's a full linear model of everything that went into my top serial number that was produced, ranging from lot numbers, unique characteristics, and even internally developed numbers. We don't need an ERP to generate serial numbers for us. We can generate a serial number, lot code, and timestamp based on the manufacturing process to see how did we actually make this thing and put it together and connect all of my sub-assemblies internally, even if it's not an off-the-shelf component coming from one of my suppliers, because we have this documentation record of everything that happened. And that's also available as part of our video series, really hammering home that traceability point.
Steve, I think it's worth giving a shout out to our traceability implementation checklist. I know we just dropped it in the comments section, but one of the things we hear about, and I know you'll talk about this in the next slide, is how do I begin formulating a digital traceability program? I've been running on paper for years, or if not decades. What should I do as my first step? And then what is step number 2 and 3? So we've tried outlining that for you. So it's just very digestible, and just encourage everyone to check that out.
Absolutely, and that's a great point, and I think that's highlighted in some of our customer messaging on the next slide. Both the first two from Elliot and Chris talk about really establishing a baseline of how do I get started and what's the right answer and where am I going with it? Because one, I want to be practical. We can talk about, eating an elephant one bite at a time. We don't want to boil the ocean. Pick your favorite metaphor. We want to make sure we want to be practical about what we're doing. It's not expensive to buy low distribution friendly scanners to start collecting this information, because we want to deploy that traceability from our new products that are getting launched on the line all the way through those R&D builds to pilot production, and then our serial production once it's fully approved by our customers and new product development. It's easy to get started, but we want to make sure that we're not trying to do too much and solve for world hunger without collecting all that information as we might expect to from those engineering builds or prototypes. And this ranges from small shops that are trying to get their foot in the door with a new product launch, all the way up to established customers that are trying to get off of paper travelers. We don't need to replace paper all in one fell swoop, but we can start with that Pareto of really important things as we're documenting what we're trying to do. And that really transitions well to what Chris is talking about and knowing your end goals in mind. Is it a customer thing? Is it a quality ISO certification thing? Or is it a large scale connectivity problem? There's questions that are framing the metrics of how are we trying to implement this traceability in this documentation. Because when we talk about, are we trying to reduce scrap? Are we trying to reduce our warranty claims? Are we trying to just lower our investigation time to give our manufacturing engineers and our sanity back? All of this is important content to know what is the end goal to try to, when we're talking about serializing and traceability, what are we actually trying to get out of it? Because if we're like Greg, we want to make sure that we have the results that we're looking for, because if we're just doing endless continuous improvement projects and we're not measuring what we're trying to be successful at and how we're improving, we're not going to be successful. So when we talk about what Greg's been working with, it's that my fault versus your fault mentality of, we have the manufacturing record, we know it was good when we left the building, we have those clear verifiable records, so we're minimizing the warranty claims or other customer issues that might be coming in. Whether you're a 10-person manufacturing shop all the way up to hundreds of employees on a shift, those RMAs or return material questions really bog down time and lower the efficiency of the overall shop, not just something happened to one of our consumer goods and now we have to figure it out. So on the next slide, I want to talk about some of these practices that we've put together about combining work instructions. There's a couple other tools that we highlighted during the series because we want to combine these as part of the overall platform experience for the operator. Yes, we talked about work instructions and layering in all that content, but there's other features or aspects of a new live platform that really allows us to transact our information. So when we integrate with those other systems, we can reference that bill of materials that we talked about. We can pull in and complete those work orders and manufacturing orders from the system, so we don't have to waste our operators' time transacting in multiple systems, because in reality, they just need to reference the work instructions, collect the traceability information they need to, and complete the job and have the inventory transact, so we have a good view of all of our work in progress and raw material. It just allows us to transact appropriately, not waste our operators' time, and make sure all the financial and accounting folks are happy with appropriate inventory reporting information. The other two aspects that are important in a live system like this, even as simple as a internal home-built 3D printer, we can deploy updates and manage revisions. So if I need to go back to see when did I build this and what version of the work instructions, how many updates have I made since that time, and make sure I have all of the updates that I need to if I'm building this at myself or I've got a partnership group in a shared space in a workshop. Those same principles transfer to the factory of I want to make sure everyone's working off the same set of instructions when I expect them to. So if I push out version 5 for myself, it's instantly available for all my coworkers and operators when I would expect to. Then finally, an interaction point of sending those alerts and making sure the operators can provide feedback of I've got quality instructions and I want to make sure that I can give feedback accordingly. So that banner that just popped up about signing up for free, because we've launched a specific aspect of our platform. We want to make sure that work instructions are equitable for everyone. You can sign up for free at picomes.com/try for free for a not time limited free trial. It is a full deployment of work instructions and be able to start seeing how this might work in your factory and managing some of that content internally. So it's a great place to get started. And there's a link in the comments for you to try for free as well, to link directly there to get started, because we want to make sure that everyone has the ability to do this without any barriers to entry and get started immediately without having to worry about internal tools like PowerPoints or PDFs that we're using today, because it's free. We want to make sure those work instructions are equitable for everybody. So before we start wrapping up, I want to talk about, the high level factory from scratch idea that I know a lot of you are in a system where, there's maybe a home built ERP, a home built MES, some legacy software that you're working with, or there's processes you like or don't like. When we're talking about starting over from scratch and you're building a new factory, or if you had a blank slate, what would you do? What are those current systems that you have that you would actually carry over? I know in my past life, I've run a few different factories. There's aspects that probably worked pretty well. We have those reporting aspects and that content, but we have paper checklists and a ERP that doesn't transact directly from the shop floor. My operators having to do repeated work by doing my job, writing everything down, and then going to tell the computer what I did throughout the course of my shift. That's a lot of added time where it just doesn't get us to where we want to be for the factory of the future, right? Where there's a lot of industry 4.0, industry 5.0 about AI, but if we're doing AI baselines on bad information or ERP that doesn't have good information, we're just copy and pasting bad information and not doing the right level of learnings and expectations. So when we talk about a system like Pico, even in the example of the digital 3D printer, we want to make sure that we're establishing those good behaviors right away. So even if I am starting small or only collecting a little bit of information, I know my data baseline is good. So I can actually start leveraging those next gen technology efforts on top of it, because it's coming straight from the source of truth from all the tools that are doing the manufacturing, and has a high level of operator activity because it's easy to use and stays out of their way at the same time to make sure our baseline is confident and good. So I think when we're talking about, the factory of the future, there's aspects of what you're doing that are very strong and preferable, but there's things that we can all do a little bit different to change the pace there.
Awesome. Thank you, Steve, for that explanation of our series and what we're trying to do here. So again, for everybody, if you haven't watched our episodes yet, the first 4 episodes are out now. You can watch those on our website or on our YouTube channel, and we'll drop the links in the comments to access those. The 5th and final episode is going to come out tomorrow. And then after that, the entire series will be available for you to binge watch at your leisure. So if we go to the next slide, we'll go through some final next steps here. So again, head over to picomes.com/try for free to sign up for your free digital work instructions. This is a free forever cloud-based deployment of digital work instructions, and you'll be able to start digitizing your processes. If you're at the point where you are ready to start implementing traceability, we do have an upgrade plan available for you at $100 per user per month. That is our essential plan. You can see that on our plans and pricing page on our website. And then finally, if you want any more information on this series, go ahead and download our free guide to airproofing industrial equipment assembly. You'll find more details on the series, what we do, and some more tips and tricks there, as well as the free guide to writing effective work instructions that we mentioned, and also the on-demand webinar to go along with that. There's some great advice on how to write clear and concise work instructions for you. So if you do have any questions, feel free to pop those in the comments and we'll answer those for you. But yeah, I guess before we head out, Steve or Joyce, do you have anything else to add?
Well, I just want to call out what's on the banner in front of us. What has been your favorite part of season one's episodes? For those that have been following, like Sarah said, we're only one episode away from finishing the entire series. So what did you enjoy? Did you enjoy that we filmed in Steve's living room in the suburbs of Milwaukee? Did you enjoy looking at his luscious plants? Did you enjoy the content? Was it helpful? Did you learn anything? Those are all really helpful feedback loops for us as a team so that we can continue making good content for manufacturers. I think the second thing I'll ask is what should be our next application? So as this season was on 3D printing, next season, should we do an aerospace drone? Should we do a lawnmower? What kind of applications are representative of the challenges that you're facing in manufacturing that we can also help address? There you go. What should our next application be?
Awesome. Okay, great. Well, I think if there's no questions, we can probably wrap up. Again, everybody head over to our website or our YouTube channel to check out the series. Again, final episode comes out tomorrow, and then you'll be able to watch the whole series on demand. So thank you, everybody.
Sarah, we do have a question that just came in.
Oh, great.
The question from Melissa is, what does deployment look like with Pico? Maybe Steve, you can take that one.
Yeah, I'd love to. So I'll kind of start from the try for free version that we already mentioned and work our way down the path from there, because I think it's just important contextual information. So when everyone starts with a try for free, or if you'd like to start there, it's certainly not the only option, but that's the most common for what we've seen. When we start for a try for free deployment, it is a cloud-based deployment in your time zone. It's all domestically hosted in the US for our domestic listeners, and then your relevant overseas area for Asia Pacific or Europe. Those are all cloud hosted environments. When we start talking about upgrading from that try for free model, we have the option of staying in a cloud, making sure that you are in your own deployment environment, but also we have the option of going on premise, which we actually start to recommend when we talk about the platform of Pico, of connecting to those IoT layer of things, or OT technology, operational technology that is typically available in factories. We don't necessarily want to have that constantly going out of the factory. If it lives on your local network, we can provide our server and our hardware to do the same, or deploy on a server rack using a virtual machine as well. So we want to make sure that you have that flexibility for that cloud deployment, or hosting an on-premise server for those of you that have those connected tools, or those stricter IT environments where we want to make sure all of our information is behind the factory's firewall and where it's safe and comfortable for all those types of compliance.
Okay. If there are no more questions, I think we can officially conclude. Okay. So thank you everyone for joining us. We'll see you next time. Goodbye.